Happy Pi Day! It's 2020, this year's Pi Day, it's today, and I would like to do, it's not really today because I'm recording this a couple days early, but I would like you to see this on Pi Day, a coding challenge themed around the number pi. And thank you to Fatin Bibas, who suggested this one, Pi Day, find a sequence in pi, issue number 1464. I wonder if those numbers are where they are in pi. Ooh, we'll find out by the end of this video. How to look at how one might search for any given sequence of numbers in pi. Now, in this suggestion, this particular website, angio.net/pi, is mentioned. It has a bunch of different resources, a resource of where you can download all the digits of pi, a place to search for pi. This all reminded me of a wonderful project from Fathom Information Design. So if you don't know about Fathom, they're an information design firm founded by Ben Fry, who was one of the creators of processing itself. You can find out more at fathom.info. But they created this project, Peek Inside Pi, which you can play with at pi.fathom.info. There's also an app version, a lot of other versions. I'll link to all those things in the video's description. So the idea here is that I can type, or I could tap. Can I tap? Where is it? Oh, it's not working. My touch screen doesn't work. The point is, for any given sequence like 14159, and there it is, it's found at the first digit of pi. So now, let's pick another sequence. Like, what's a wonderful sequence? It is, today's date is March 14th, 2020. And that is not in the first 1 million digits of pi. Ah, if only we had more digits. I must have more digits.
Coding Train breaking news.
I'm told that I should search for the number 999999, which is the 762nd digit of pi. So let's remember that and make sure when I write my own version of this that I find the same digit. I'm going to do this with P5.js, JavaScript in the browser. It's not going to be as nicely designed with a beautiful interface like this, but I'm first going to recreate this exact thing. And then what I'm going to do is I'm going to go from 1 million digits to 1 billion digits and see if I can still search for any digit in pi. And probably I'm going to fail because we're going to need some kind of like optimization. It's all going to run too slow. Everything's going to come crashing down. But I'm going to try nonetheless, and we'll see where we get to by the end of this video. I'm starting with a simple P5 sketch and 2 text files. One with 1 billion digits of pi, which is just a megabyte, and one with 1 billion digits of pi, which is a gigabyte. That's a much bigger file. So let's start with the 1 megabyte file. I've uploaded that file to the P5 web editor, and I can load all the text from that file right now using preload. I'm going to just take away animation here. I'm going to get rid of the draw loop, and I'm going to say no canvas. And then the file itself has all of the digits in pi in one line. But load strings loads text files into an array, with each element of the array being a different line of the text file. So what I'm going to do here is create a variable called digits and just say it is the first element in that raw data array. Let's console log digits and just see what happens. OK, so all of the digits of pi are down here in the console. Now what I want to do is search for a given digit. Let's make an interface, a very, very crude, simple interface for searching. So now I have this tiny, tiny search box up here. Can I make that bigger? I also just increased the font size for any input element on the page so it's a little easier for you to see. The interaction that I'm looking for is anytime anyone types anything into that search box, I want to look for that string, those digits in pi itself. And P5.js has a special event function called input, which you can call on the search box and pass another function that will be executed anytime a change has been made. So let me write that search it up function, because that's when I'm looking for something, I say, search it up. I'm going to be a little silly and make these global variables. Then let me get what I'm searching for from the search box and console log that. So now, whenever I type anything into that search box, I should see what I type here in the console. And that's working. This is going to actually be a really easy project to do. You know why? because I could just use the IndexOf function in JavaScript itself. Let me do that real quick. Just please, can I just do that real quick? I'm going to do that real quick. Digits index of search. This is saying look inside the long string digits and give me the index of wherever this string search happens to appear. If it doesn't appear, I'll take a -1, please. Let's make another element on the page. So now when I get that index back, I can say index p.html, that index which will put the actual index where it's found in the paragraph text there on the web page. So for example, if I say 14159, why does it say 2? So really when counting the digits of pi, what seems to be the convention is the first digit is the first digit after the period. So it's 3 point, the first digit is 1. So I should really say index -1. And now 14159, I got 1. And then what if I say 9999999? We got it! 999999 appears at the 762nd digit in pi. So if it's a 3, I don't want it to find that 0 digit, so I'm going to start searching from index 2. The chat is also rightfully pointing out that I could just chop off the first 2 digits of the string. That would be much too easy. I'm going to do it this way. So I'm going to start from looking at digit 2, and I'm going to say, as long as index is greater than 0, set that. Otherwise say, otherwise I'll put a message about it not being found. Okay, so let's try. 14159, 999999, not found. So I now have essentially, without the care and thought into the interaction design, the visual design, the layout of the page, all of those elements, recreated my own version of this peek inside pi. This video is not over though. I got 2 more things I want to do. Number 1 is I want to just investigate what does it mean for me to actually perform this search myself, to write my own IndexOf function. Because maybe if I do, that might unlock some other creative possibilities, and also I might learn something about programming. And then let me increase things to 1 billion digits and see what happens, what breaks down once I have a 1 gigabyte file that I'm loading all the digits of pi in, as opposed to a 1 megabyte file. All right, so let's first write our own IndexOf function. So I'm just going to change them to comment this out, and I'm going to say let index equals index of a search in this string for this search string. Okay, so search in the string digits for the string search. And so the function looks like this. Its name is IndexOf. It needs to receive a block of text and the substring that you're searching for in that text. Let's start with what's the first character in the search string. Then I want to iterate over the entire string of text and say, hey, does this character in the entire string of text match the first character of the search string? If so, I need another loop. Then I need to loop through all of the characters of that search string. This is supposed to say 4. So I don't need to start at 0 because I've already checked to make sure that's 0. And I want to check, is text car at I plus j the same as search car at j? Now, again, I'm not worrying about running this optimally or elegantly. I just want to get the core idea out. So let's say this is my text. And what I'm looking for is, I want to find out where is 415 in that particular string. This is my search. What I have going on here is I know the first character of what I'm searching for is 4. So I, the index I, is starting here and looking, is that 4, is that 4, is that 4, is that 4? Aha, this is 4. Now let's save this spot. And then based on this length 3, which let's iterate over this length with j, 0, 1, 2, and let's add j to I, 0, 1, 2, and see if all those digits continue to match. So ultimately, really what I'm looking for here is any of those digits that aren't the same. So I really want to look for, first I'm going to be very strict about this and use the triple equals, and then I'm going to say not equals. I'm going to make a guess that I found it. As soon as I find the first character to be the same, aha, I found it. And then anytime I find anything to be different, I can now say found equals false. So the question becomes, right here, if found is true, then I can break out of things. And once one is not true, I don't need to check the rest, so I can break out. And then, if found, return what? So I'm going to say let found index equals -1. I'll give a default value of -1. And then, actually, if I've found it right here, found index should equal what? I, wherever we started with, I. And then if I've gone through every possibility and I haven't found it, then I'm going to get to the end and I'm still just going to return -1, but found index will have -1. So if I found it somewhere, I'm going to set it equal to that first index, get out of the loop. I don't need to check anymore because I'm just looking for the first instance and then return what I found. Let's run and see if this works. No. Found is not defined, sketch line 22. This if statement has got to be inside here. This is where I'm looking at every single character in the large string I'm searching through. As soon as one of those characters is equal to the start, check all the subsequent characters, and then if I found it, break out of that larger loop and keep going. So this should be right now. I'm sure there's other mistakes, but that will be fixed. All right, 14159 at digit number 1. The chat is giving me a nice suggestion where I could simplify this code where I don't actually need this found index because I could just return I, which will automatically break out of the loop. And then if I get to the end, I could just return -1. Great, so this works. Let's try the 999 thing. There we go. So this really wraps up a small piece of this coding challenge. I have made my own version of Fathom Information's peek inside Pi. I even wrote my own string search function. There's so much more that you could do with this to be creative. I mentioned at the top that you could think about what if what you weren't looking for were just numbers, but you were looking for some other piece of data that's encoded into numbers. So could you find secret messages in Pi or pieces of music in Pi? Are there other kinds of algorithms that you could explore that you could optimize this particular search algorithm with? And I'll list some of those in the video's description. That's a little challenge out to you to research some of those and tell me about your favorite substring search algorithm in the comments. But those are going to be needed for when I take the next step and attempt to get this working with 1 billion digits of pi. And for that, I'm also going to need a node server. So at the very least, I could be like, oh, OK, let's run this exact same code. But now let's take a text file that has 1 billion digits of pi. So I'm going to go back to add file here. And I'm going to go back to my file system. I'm going to come over here. I'm going to find my 1 billion digit pi file. Drag that into the browser here, and the web editor will not let you upload a file that big. And even if it could, am I really going to expect my client-side code to load a 1 gigabyte file with 1 billion characters in it? Now, there's plenty of ways probably that file could be compressed, encoded in a different way, probably get down to like 600 megabytes or something. But whether it's 600 megabytes or 1 gigabyte, I've still really got the same problem. I have this like huge file. So rather than try to work with it client-side in any type of clever way, I'm just going to use a node application. By the way, I could probably do this in processing because a desktop processing is not going to have any problem loading a really large file. But I want to stay into JavaScript. I'm going to create a node server that can load all of the digits, store them into memory, and then my client-side JavaScript code could query that node server. Now, if you've never used Node before, I do have a few basic beginner tutorials about installing Node and getting set up with Node, and I'll refer you to those. But I'm going to start from the point where I have a directory with a blank JavaScript file, a package.json file to describe my project that I'm building, and both a 1 million digit and billion digit file of pi. So I'm going to start by working in index.js to write some code to load that file. So first I need to require the file system module. And one thing that I could just do is just with the million digits of pi. Let's just read file sync. Let's just read the whole file in. Oh, interesting. So the file has been read in, but look how it's being displayed. It's giving me the binary information into the console. So I want to tell it that I want to read it as a string, and I'll use UTF-8. So that's a second argument to read file sync. And now, here we go. And there's all those digits of pi, all those 1 million digits. Now let's just change it to, why not? Change it to a billion. What could possibly go wrong? Oh, interesting. It did something, but it didn't print anything out. So I don't know. This is just basically a bad idea. I don't know whether something crashed or memory ran out, but read file sync for a gigabyte file is not a good idea. And I think what I want to investigate here is create stream, create read stream. So let me just look for that. On the node documentation page, create read stream. So create read stream is a function I can call to open up a stream for reading the file, so I can read it bit by bit. I can kind of track how long it's going to take and get what I want and piece it together. It just gives me a lot of options. So let me do that by saying stream equals fs create read stream. And let's go back to the million. And then once I have a stream, I believe that I can basically handle different events. So for example, I can say stream on data. That's when anything is actually coming in. I can then have a callback function and just console log the data. So now if I run this, hopefully I'm going to see all of those digits streaming out. I'm still just going to use the million digit file. Okay. Oh, I'm getting the binary data. So probably I can say just data to string. Great. So that's the million digits of pi. I'm sort of curious to do console.log, like how big are the chunks that it's reading this in? Yeah, you can see these are the chunks that it's reading the data in. They're pretty large because I put some line breaks in between each chunk of the stream. In fact, I think a lot of examples use the word sort of like chunk here. So now let's try 1 billion digits of pi. Huh? Okay. Boy, this is taking a while. There we go. All 1 billion digits. Could I possibly just put them all into one string? And then, if I have stream on, I believe it's end. I think there's an end and a close. And by the way, if this arrow syntax isn't familiar to you, it's a nice way of writing callback and anonymous functions, and there's a lot more to it than that, and I have a whole video about arrow functions that you can watch. Let's just do digits.length and see if we get 1 billion digits. Digits is not defined. Data. Digits. And look at that, it's 1 billion and 2 because the 3 and the 1 don't actually count. Okay, now let's just search for a digit. Let's grab my IndexOf function that I wrote previously and bring it into the node code. And then let's look for, I'm just going to hard code this. Let's search, what was I looking for? 999. Let's look for 999. And then index of digits search, and then console.log index. $763. Oh, -1, -1, -1. Okay, so that works. Now here's the thing. That didn't take very long because that is actually found at 762. Does anybody know of a sequence of digits that's very, very far into the sequence of a billion digits? That would be helpful to know. While you're thinking about that, for those of you who happen to be watching this live, not in the recorded video that you right now, not you watching this live, but you watching this later are watching, let's just quickly add in a web server so I can make a call to ask for the location of a given digit. So in this video, I'm not going to go through all of the pieces of adding a web server and how HTTP requests work and GET requests and response and all that stuff. But guess what? If you're interested in a much lengthier series about all of the details that I'm going to add quickly right now, you can find that in the Working with Data and APIs in JavaScript a learning playlist that I have on this channel. But for now, I'm going to go and copy paste, but I'm copy pasting from the code that I have for those examples. Right here, I want to create an Express app. So I'm going to add an Express app. I don't need this database stuff, so I just need to create an app, Express. I want to listen at port 3000, and then I need just a GET request. So I'm going to grab this. I just want to handle one route. I'm going to say GET whenever I'm going to just call this route search. Actually, I'm going to call this pi. And then I'm going to use, what are those things called? Restian routes, something like that, to look for some sequence of digits. And let's call it search. Let's keep it with search, some sequence of digits. Request params digits. So basically, I have a simple GET request. Whenever I run this server, anytime somebody navigates to search / some sequence of digits, I'm going to pull out those digits and just send them back. I'm going to get rid of just this on-end stuff right now. I don't need this. Actually, I'm just going to write console log billion digits loaded. And let me run the server. Error. Oh, I've got to install Express. So Express is a nice framework for making web servers in Node. Now let me run it again. So I'm listening at port 3000. The billion digits are loaded. I'm going to go to localhost 3000. There's nothing there. But now, if I go to /search /1 like 433254, I see it. I got it, and I sent it back. Guess what I can do now? Oh, this is really exciting. So if I take this code where I was searching before, and I bring it up here, and I can say search equals request params digits, search for it within the digits, and then send that response back. But ultimately, I want to make this JSON. So I'm going to say index. I'm going to make this a nice little JSON object. And I'll also send back what was the search string as well. So let's try this one more time. And let's switch to 1,000,000 digits. So I'm going to just change this to 1,000,000 digits. Go back to the browser, hit refresh. Oh, I've got to restart the server. Go back to the browser. And there we go. This particular sequence of digits was found at that index. Let's double check this with Fathom's peek-in-pi. The digits were 43324. It's found at the 35,572nd digit of pi. Is that what I got? Yes! That's what I got. So my search is working, and now, let's change it. Well, let's get it working from our interface first. Then we'll try it with 1,000,000,000 digits. So now I don't want to just do this by hard coding this into the browser. I want to go back to my P5 code. And in my P5 code, I'm not going to load the data file there. I don't even need to do the search there, so IndexOf can go away. But whenever I want to search it up, instead of actually running the search, I'm going to make a GET request. So I'm going to say load JSON. The URL is localhost :3000/search, and then add in the actual search value. This is a string literal, which is an incredibly convenient way to put a variable into a string. I'm going to call load JSON got result, and then when I get the result comes back in index. And that is where I'm going to put it in the paragraph. So I can get rid of these things I don't need. So basically, this is just the interface. And the interface, whenever interface goes and asks the server to look in the digits, with the server being the one that can handle holding on to those billion digits. But I need to host this web page. And the way that I'm going to do that is use Express the same Express server that is serving up the digits of pi, the index value into the digits of pi to serve up these web pages. And that I can do with adding like express.static something or other. Let me go look back to my older tutorials about this. It's right here, app.use express static public. So I want to host everything that's in a directory called public, which happens to be what I just called it, back into the server. There we go. And you can see I have this, the P5 sketch that I've been working with is in the directory public. We don't need this million digits of pi anymore. There, it's not part of the client at all, just part of the server. Let me restart the server. Let me go to localhost 3000. Uncaught error, raw is not defined. So I've got some errors in my P5 code. Oh, I don't need, the digits no longer belongs here. There we go. Okay, now. Ooh, okay. It's searching. It's always finding -2 because it's searching for this like colon. What? Where did that colon come from? Where did I put that in by accident? Oh, look at that. Oh, it's just an extra colon that I had actually in the string. That goes away. Bye, go away, colon. It works. It's searching in pi, but the searching is happening on the server. So now it's time. This is the grand finale of today's Coding Train Pi Day Challenge. We are going to search in 1 billion digits of pi to find any given sequence of digits. It is time. I'm going to do it. To go back to my server code. That was anticlimactic. I'm going to change it to loading the billion digits of pi. I'm going to restart the server. I gotta wait. It loaded the billion digits. It's now waiting for me. Going back to the web page. Let me just refresh this web page. And I don't know, let's try. Searching. Question is, has it found it? No, it didn't find that. So somebody needs to fact check this for me. Is that sequence not in the first billion digits of pi? David suggested a string, 207-75510. Let's see if that works. 207-75510. This is at digit number 176,866,377. That's pretty good. Oh, I have an idea. Let's look at what's in that text file, the last few digits. Digits.length minus 10. I could use like substring or something, but I'm just like afraid. So let me print out the last 10 digits. Oh, no. Digits, car at. Okay. Does it really have to be like this? I'm doing this in the weirdest, most nonsensical way. So with a little detective work, I have determined that these are the last 10 digits in the first billion digits of pi. So just to see how slow is the searching, I'm going to refresh this page. And I'm going to paste those last 10 digits into here, and we're going to see how long it takes. There we go, it found it. That's not so terrible. So we can, even with my crude brute force algorithm, find any sequence of digits in the first 1 billion digits of pi by having both a server and client talk to each other. So many possibilities here. How could you optimize the search algorithm? How could you make the API do all sorts of more fun, creative things to give you more information about what's in pi? Could you put this onto Glitch? So maybe we could make this like, Glitch is a hosting website that allows you to deploy different kind of creative web applications. So maybe I could make a version of this that runs on Glitch that people could remix. I will include a link to that if I can get it to work in this video's description. And you could just be much more creative about the interface. And once again, what are you actually really searching for? Could you search for secret messages in pi by thinking about encoding text into digits? Music in pi by encoding musical notes and melodies and rhythms into digits, colors into digits. What data could you search for in Pi, and what wonderful things could you discover that way? And maybe you could find a text file with more than 1 billion digits and make your own version that searches into an even larger number of digits of pi. I hope you enjoyed this Coding Train Coding Challenge Pi Day. Thanks to Fathom Information Design for the inspiration with peeking inside Pi, and thanks also to Fontaine Bibas and all of you watching this live on during the live stream with all of the suggestions and help that you offered. I'll see you soon next time on the Coding Train. Have a great day, ride, all aboard, all that nonsense. My catchphrase. It's coming one day. Oh, this is my catchphrase. It's not a phrase. It's a sound. It's a train whistle sound. That's my catchphrase.